Good evening, everyone. My name is Arna Moores, and I teach up at Simon Fraser University, and I've had the pleasure of moderating the And You series now for a number of years. And this incarnation is called Solutions and You, Combating Climate Change. And this came from you, indeed. We were told that we'd been giving too many talks outlining the problems associated with global change, and you wanted to hear a little bit about the solutions. And so we did that a little bit last week, and we're going to continue through 3 more talks. So the other difference from previous series is that we actually have 2 speakers. So I will introduce the first speaker now, and then he will give the standard 45, 50 plus minute discourse. Then you'll all stretch, as we did last week. And then we're going to have a second speaker, who I will introduce at that time. It's Professor Mark Jaccard from Simon Fraser, who will act as a sort of respondent and place some of what our speaker has said in the Canadian context and bring in perhaps some other things, and then we open it up for discussion. And it worked quite well last week, and I expect it will work as well or even better this evening. So it is an honor to introduce Dr. Chris Hope. Dr. Chris Hope has been working at the Judge School for Business at Cambridge University in the UK for 25 years. And for most of that time, he's been working on a particular model called the Page model, which tries to put a cost on carbon. Now, before that, he did his PhD actually at Cambridge, but before that he was actually a physicist. So he went to Oxford, the other place, and he got a degree in physics, and then his first job after his first degree was at a physics institute called Harwell, which is in Oxfordshire, and he was a physicist, but he was working on, okay, which renewables should we actually be investing in? So the government actually was caring about this some 30 plus years ago. And he was working there as a physicist, but doing sort of the policy side, and they thought he was so clever that they said they sponsored him to go do his DPhil at Cambridge, and he's actually stayed there. And those old universities tend to just hold on to their best people rather than send them out, which is what they should do, of course, but they don't. So this model was influential in the Stern Report, which you've all heard of from 2006, and I showed a picture of Sir Nicholas Stern now. Very influential report on the cost of climate change. And that same model, and he'll talk quite a bit about this model, I think, this evening, is actually used by organizations like the EPA, Environmental Protection Agency in the US, that tells Obama, or any other president, what they should be doing and what the sorts of policies they should have in place, for instance, on emissions from your car. So this is not just academic, this is actually the kind of academic that goes straight into, what Volkswagen should have been doing, right? So, with no further ado, I turn the floor over to Dr. Chris Hope. Join me in welcoming him, please.
I'm mic'd. Thank you, Arnie. Thank you for that introduction, and thank you all for welcoming me to Vancouver, somewhere that I've always wanted to visit because people tell me how wonderful it is, and I've been here for 4 days, and indeed it is as wonderful as people say it is. So what I'm going to be talking about tonight is how big is the bill for global climate change? Both the total bill and also the bill that each of us faces because we emit greenhouse gases in our driving, in our life, in our electricity that we are using. And because both of those 2 things sound a bit like what Arnie said you've been fed up with hearing about before, which is the problem, I'm also going to go on after that and talk about how knowing about what the total bill is and what the bill is from each ton of greenhouse gas we put up into the atmosphere, how that then leads us to possible solutions, possible things that we can do in order to get a handle on this issue that Nicholas Stern called the greatest market failure the world has ever seen. So I hope that by the end of my 45 minutes, although I'll go through the modeling and go through the results of describing how we work out and how serious the problem is, we'll get to the end where we have some proposed solutions which will actually benefit the environment and benefit the economy. And that's, of course, what we want to do. So I'm going to just start a little bit by saying what the need is for evidence, why should we be doing this kind of analysis. And then I'm going to talk about this model that Arne mentioned, the PAGE model, which I've been involved with developing for the last 25 years or so. The latest version, the current version, it's called PAGE 09, and it works out indeed these impacts from climate change. I'm going to talk therefore about the total climate change impacts, which is the first thing, the total bill. And then I'm going to talk about the social cost of carbon dioxide, which is the second thing I mentioned, the bill that we face for every ton of carbon dioxide we put up into the atmosphere, the damage that causes. And then I'm going to talk about the policy implications of doing the right thing with that information and leading us towards some solutions. So, you know, you've all seen these kinds of statements. The alarm that we have about climate change, I'm not going to read them all out to you, except the first two are quite old, but they're notable because they come from people in the UK who are not sandal-wearing hippies. These are guys who are right at the heart of the establishment. David King was the chief scientific advisor to the government. Lord May is president of the Royal Society, the oldest scientific society in the world. And they make those kind of statements about climate change. And then we've just had the encyclical from the Pope, which is at the bottom. Not quite such alarmist language, but undoubtedly pointing out that this is a problem with grave implications, all sorts of implications. And it represents one of the principal challenges facing humanity in our day. Seems fairly clear, but then you get this. Okay, so over time, things wax and wane for public consciousness, and studies that have been done show in 2011 that the American public was less likely to believe in global warming than it was 5 years previous to that. We've got Tony Abbott, and I sent this slide a couple of weeks ago, at which time Tony Abbott was the Prime Minister of Australia. He no longer is, he's been displaced, Malcolm Turnbull now, but he was completely unconvinced about climate change and the reality of it, and that's the quote from him. We have James Inhofe, a senator in the US, saying it's a hoax. Some people are so arrogant to think that they're so powerful they can change the climate. Man can't change the climate, and I believe he threw a snowball at somebody just to prove that it was cold and therefore we can't change the climate. And then if you want a slightly more academic research on that, the Pew Research Center published just a month or so ago a study that only 27% of Republicans in the US believe that humans are primarily responsible for the Earth getting warmer. 71% of Democrats believe it. But, it's a small proportion, certainly, of Republicans, one of the two main groups in the US. So we've got these two things. We've got somebody saying it's the worst problem ever, it's incredibly severe, and some people saying it's a hoax. So what do? Well, the way forward that the Royal Society believes, and I think it's a good way forward as well, is it's vitally important for nations and regions to use evidence-based policy when they're deciding upon what responses we should have, for both mitigation and adaptation. These are the two things that we can do to try and cope with climate change. Mitigation is reducing our emissions of the different greenhouse gases. Adaptation, building up seawalls, adapting different crops when the climate changes and so on, to reduce the impacts. And then even back to, again, an academic statement from really brilliant American economist, Robert Solow, in 1993, made the statement at the bottom. In this complex world that we have, people populated by people with diverse interests and tastes, enmeshed in uncertainty about the future, not to mention the past, there's a lot to be gained by transforming questions of yes or no into questions of more or less. In other words, the yes or no is, yes, climate change is the worst thing ever, no, climate change is a hoax. That doesn't really get us very far. Yes or no lends itself to stalemate and confrontation, more or less lends itself to trade-offs. And the kind of analysis that I'm involved with is trying to help us work out the more or less that we should be taking as actions to deal with climate change? Should we be putting a bigger price or a smaller price? What kind of action should we be doing? And indeed, I'll put my cards on the table right now and say that one of the reasons that I wanted to come to Vancouver and British Columbia, as well as being a beautiful and wonderful city, is the fact that it's one of the few places around the world that has made some serious attempt to apply pricing to dealing with this problem. So Bill Nordhaus is a famous economist from the US. He says the inconvenient truth from economics is this: raising the price of carbon or carbon dioxide is necessary for implementing policies in a way that will reach the multitude of decisions and decision makers over space, time, nations, and sectors. Okay, it's got to reach millions of people here. You and I, when we're deciding what kind of car to buy, or indeed whether to go by public transit rather than car, we have to be deciding all the time on these various issues. And pricing is one way of making us nudge towards something which will be cleaner and greener rather than dirtier. And then the IMF, the managing director, Christine Lagarde, recently has said getting the prices right means using fiscal policy, using pricing, using numbers, to make sure that the harm we do is reflected in the prices we pay. So we need to try and work out what harm we're causing by our emissions of carbon dioxide and other greenhouse gases, and have some prices which reflect that. Well, how do we do that? I will talk about the evidence that there is very, very briefly for climate change, because I know you've had Michael Mann here last week and he's far more of an expert on that aspect of climate change than I am. So this is just a little refresher, just a couple of slides. In the past, what we've had is concentrations of CO2 over the last 500,000 years or so staying within this range. You know, when it's down here, we've had ice ages. When it's been up here, we've had interglacials that we are in now. And this is where we are today, and this is where it appears we're heading over the next 100 years or so. An instant, in geological terms, rise in CO2 concentrations far beyond any range that we've seen over the last 500,000 years while humans have been on the Earth. And what would that mean if we were to have that over the next 100 years or so? The Intergovernmental Panel on Climate Change has looked at this and talked about and looked at the modelling evidence for what that will do in terms of changes in temperature. And here we see what we've seen up until the turn of the century, maybe about a 3/4 of a degree rise in global mean temperature. And here are their views of the future of what might happen in the next just under 100 years to global mean temperature. And the path that we seem to be on is, at the moment, somewhere between these two, A1b and A2 scenarios. So what we would then be expecting to see, the middle lines here, is maybe 3 degrees rise from the turn of the century, nearly 4 degrees rise in temperature compared to pre-industrial times. But we could be unlucky. This is the range of uncertainty around here. We could be up 5 degrees above today, 6 degrees above pre-industrial. And all the implications of that, well, that's something that Stern looked at, and there are various other people, like the IPCC have produced these, they call them burning embers diagrams or arrow diagrams, saying all the nasty things that might happen. So here along the top is what happens if the temperature rises. You know, we're about here now, nearly 1 degree above pre-industrial. And here's what might happen over the next century. And if we have sort of no arrow or light yellow, then there's some small risk of this impact occurring. If it goes into the red, then it's likely to be a large impact or much more certain to occur. I'm not going to go through these in detail, but just to say there's all sorts of areas: food, water, ecosystems, extreme weather events. I know you've had some extreme weather events here recently, windstorms and so on. But the one at the bottom that people really have nightmares about, Stern called it abrupt and major irreversible changes. The IPCC call it discontinuities. I say, use the correct language, it's catastrophes. Okay? It's the Greenland ice sheet melting and the West Antarctic ice sheet melting. And then the sea level rise, instead of, you know, here being maybe half a metre or 1 metre if those things don't happen, if the ice sheets don't melt. It would be 13 to 15 metres of sea level rise if those ice sheets melted. And that's the thing that we have to factor in, as well as, if you like, the routine impacts of climate change on food, on water, and so on. There's the chance, the risk that we will be bringing forward these catastrophes and increasing the probability of them occurring. And therefore we have to factor that in to the decision making that we employ. How do we do that? Well, because the kind of temperature rise that we might see by the end of the century is completely unprecedented in human history, we can't just look at data and can't just look at what's happened in the past. We have to be building models in order to try and see what might happen in the future. And the kind of models that I work with and that will tell us what the global bill might be are called integrated assessment models. They're called that because they put together the best information from the scientists with the best information from economists and try and work out what the implications are for deciding what we do. So they integrate the science and the economics together. And this is a typical structure of them. I'll read it out. So at the top, you start with what might be our economic growth in the future, what might be our population growth in the future, maybe what kind of technology will we be using. And you can then work out some estimate of what the emissions will be of the different greenhouse gases, mainly carbon dioxide, but there are other greenhouse gases as well. Then you can work through the science of what the concentrations will look like over time. There's all time lags in all of this. You have to get the equations right to deal with the time lags. What will that do to global climate and what will it do at the regional level? Because different regions will warm at different rates. The Arctic is warming twice as fast as areas near the equator. And then you can work out what the impacts might be. What will it do to crops? What will it do to forests? What will it do to ecosystems, human health, energy use, all these different areas. And try and then say, how bad is that in socioeconomic terms? How can we put a price on those kind of impacts that might occur by doing the modelling in a sensible way? And when you do all of that, you can do it in different ways. There are 3 major integrated assessment models around the world, one that I'm involved with. Actually, scientists are horrified by this. It's an Excel workbook. That's what I use to do the modeling here. It's not some huge supercomputer which takes 6 months to run because it's got enormously arcane equations in there. It does have in a little bit extra than standard Excel, this at risk, but that's there to handle the uncertainty because we have to. You know, we can't ignore the uncertainty, we can't ignore the risks, and therefore you have to put that into. And it divides the world up into 8 regions because we're trying to work out, you know, is it going to be worse in poor countries, rich countries? Some of the regions are there, European Union, US, China, those are individual regions, and then the other 5 cover the rest of the world. It looks up to the year 2200 in the default version of the model. And when I say this to my scientist friends, they say, what, you only look up to 2200? And when I say it to the economists that I'm working with, they say, what, you look up to 2200? And they both think I'm crazy. But this is sort of a little compromise in between what the scientists can tell us about and think is important and what the economists can tell us about and think is important. So I go up to 2200, but the model can be used by people to look a bit further if they feel confident to do that. It looks at the impacts in these areas. Sea level rise, inundation that we might get. Economic impacts, things that affect GDP, crops, not growing as well, forestry not being so efficient and productive. It has non-economic impacts in there as well, which are things which don't get directly into gross domestic product. So that will be things like destruction of a site of special scientific interest because it's been inundated by the sea. You know, there's no impact on GDP of that, but it's something we would want to value and say this is something we probably wouldn't want to happen if we can avoid it. Or effects on human health. People dying from heat stroke. Again, no direct effect on GDP, but a value there nonetheless. And the model values those non-economic impacts. And then this is discontinuities, which is the catastrophes, which is the ice sheets melting and so on, and the chance of that, and how bad that might be. We can look all the time at two policies and the difference between them, because that's how you want to use the model. You want to say, okay, if we do nothing, what will the impacts be? And if we then do something which is quite aggressive in terms of cutting back our emissions of gases, how much do the impacts drop? And how much do the costs of doing that rise? And then you can sort of try and work out, is it worthwhile doing something a bit more aggressive because the drop in impacts is big enough to justify the costs of doing those cutbacks in the gases. It works because the whole situation, the whole climate, the whole vulnerability of the economies is so uncertain. It works under uncertainty and carries those uncertainties all the way through. 112 inputs to the model, which are carried all the way through as uncertain values. And that therefore means you have to do 10,000 or 100,000 runs to build up a good picture of all the risks that we might be facing. So that's why it can't be a huge general circulation model which takes 3 months to run, because you could never do 100,000 runs of that to build up the risks. So that's why it has to be something fairly simple on a spreadsheet to enable you to do that. Okay, so what kind of inputs are there in the model? Well, here's one. Okay, this is the climate sensitivity, and this is where I noticed that the translation to Mac hasn't worked perfectly, but it's worked well enough. I think I can describe it. So along the bottom here is how much will the world warm if we double the concentration of carbon dioxide in the atmosphere and we let the world settle down again back to equilibrium. And this should say degrees centigrade at the bottom. It's cut off a little bit. So somewhere between 1 degree and maybe 6 or 7 degrees. And what's up here is how likely it is for it to be at that value. So you can see this is the kind of thing that the IPCC reports and other scientists can tell you about and give you some fairly good information in terms of at least our range of uncertainty, because they say it's not very likely to be below about 1.5 degrees, and it's not all that likely to be above about 4.5 degrees. Most likely the answer is the world will warm by about 2.5 degrees, but there's no way yet of ruling out the slight possibility that it could be 5 or 6 or even up a bit higher degrees. So that's the kind of thing that goes in as an input into the model that I'm working when you're trying to work out what the bill is for climate change, because that's the first step, trying to get from emissions to concentrations to temperature rise. And the kind of intermediate result that comes out of the model when you're looking at how much the temperature might rise over the next 100 years or so, this is how much it's risen by 2100 under business as usual emissions. Okay, we do what the US is doing and what Australia are doing and basically just say, we're not going to try and do anything about this problem. We're going to just allow the emissions to carry on rising. And this is what we might end up with in terms of the temperature rise by the end of this century, 2100, again, as a probability distribution, as a risk distribution. Okay, so there's some chance that the people who are, so they like to call themselves lukewarmist, or skeptics, some people call them deniers. I don't really like that language, it's too confrontational. But the people who don't think this is a big deal, you know, there's some possibility they could be right. The temperature might only rise by a couple of degrees by the end of the century. But on the other hand, there's a risk that the temperature rise will be 6 or 7 or 8 degrees. If you believe this is a possibility, then you also need to believe that this is a possibility. And our decisions need to reflect that whole range of possibilities. Most likely, it'll rise by about 3.5 degrees. That's the peak of the distribution. And the mean value, so it's small over there, is something like 4 degrees by the end of the century. That's roughly where it looks as though we're heading if we don't do anything to cut back our emissions. And what would that mean? Well, we need to now try and work out from those diagrams, the arrows that Stern were producing and the studies that the economists have done to try and put some figures on that. What will that mean in terms of the impacts in dollar values? So we can look under this business as usual scenario of emissions. They carry on going up. And we can say, well, we'll put in some adaptation here. The model allows you to do that. We don't assume that farmers carry on planting stupid crops when the climate has changed and the crops aren't going to grow properly. They will adapt. And we don't assume that cities will just allow their most valuable property to be inundated as the sea level rises. We assume they'll adapt. There'll be some seawalls built to protect those properties and so on. So if you want in the discussion, we can just talk about what I mean by moderate adaptation, but basically we don't assume people are just going to carry on doing stupid things when the climate changes. I've grayed this out because it's a bit technical, but I will say it. All the results I'm talking about here are in dollars, the US dollars, I'm afraid, not Canadian dollars, because that's what everybody uses when they're looking at this issue of the year 2005. We assume purchasing power, parity exchange rates, and all the results are calibrated to somebody who is at the average wealth of somebody in the European Union. Okay? You have to refer it back to a particular part of the world, and that's the one that I've used, but I'll talk about the implications in somebody who has Canadian wealth rather than European Union wealth a bit later on. So these are the kind of results that you get out. This is the kind of thing that the model shows. It looks at each individual sector and it looks at each individual region of the world, and I could go through those, but we don't have enough time to do that today. So I've just jumped to sort of a fairly aggregated result here, which is the whole of the world and all these different impact sectors. And this is the time period that the model works for, up to 2200 along the bottom here. And this up the side is the impact each year in trillions of US dollars. And what we see from this graph is several things. First of all, at the beginning, up to about 2050 or so, the impacts aren't that big. I mean, well, if you can call under $2 trillion or thereabouts per year not big, but compared with what comes later, they aren't that big. And the reason for that is twofold. One, by 2040 or 2050, the temperature hasn't actually risen all that much, and the sea level hasn't risen all that much. But the second thing is the adaptation that we're doing is probably still fairly effective over that time period. But once we get beyond there, the temperature is rising, and we saw what it might reach by 2100, and it carries on rising beyond 2100, and therefore it overwhelms the kind of adaptation we might be able to do, and particularly in poor parts of the world, there are huge impacts that might come on. And this mean value, the most likely, the average result from the model goes up here to over 10, somewhere around $15 trillion worth of impacts every year. And here's, if the lukewarmers are right, well, it's a 5% chance we might get lucky. The climate may not be as sensitive as most people think it is, and the economies might be less vulnerable than most people think they are, and the total impacts might stay every year below about $1 or $2 trillion a year. But here's the other side of it. Okay. Actually, the ice sheets might be quite sensitive. They might melt quite early, and when they do, the sea level rise might be quite dramatic, and we might end up losing large parts of our economic wealth from being inundated in that way. And up the top here is the 5%, the 95% line. It's only a 5% chance we'll be above that. When you average all these out, you end up with this kind of thing here. And then you do the final step, and this is the final step to answer the first bit of the question, is how big is the bill for global climate change? And here's the first answer, which is the previous graph showed you averaged over all regions of the world and overall impacts, and it took the time periods into the future. This then brings together all the time periods by adding up the impacts over all the different years that there are up to 2200, and bringing them back to the present day using a standard economic technique called discounting to give you what's called a net present value. Okay, so this is adding up over all the years, as well as over all the regions, as well as over all the impact sectors. And it's a probability distribution, lots of uncertainty about it, as you would expect. It has a really quite interesting shape here. The bulk of it is in this region here of a few $100 trillion US dollars, that sort of number. But it could be out here at 1, 2, 4, 6, 8, 10,000 trillion US dollars. And these are the times that we've melted the ice sheets. These are the times that the catastrophes have occurred. These are the things that really keep people awake at night, and therefore we need to model those as well as the most typical impacts. And when you average out that whole probability distribution, the mean value of it comes out at about 400 trillion US dollars. 400 trillion US dollars. Well, that's a big number. Okay, the most ambitious estimate that people have made of the loss of wealth from the financial crisis that we had that started in 2008 is about 15 trillion US dollars. That's the total impact around the world of that. What we're talking about here is a possible impact, most likely a mean value of the order of 400 trillion US dollars from climate change. This is why Lord Stern called it the biggest market failure the world has ever seen, because these are the kind of numbers that come out of the evidence-based modelling. Now, there's a problem with it, of course, which is it's 400 trillion. How do I think about 400 trillion US dollars? I mean, it's just enormous. It's mind-blowing. You can't think about that very easily. So the better way to think about it is the way that I'm going to move on to now, which is how much impact is there from every ton that you put up into the atmosphere? Because we can think about that today. We can think about how much impact we're having from the activities that we're doing day by day, which put up a ton of carbon dioxide into the atmosphere. And the answer to that question of how much impact we get from one more ton of carbon dioxide being put into the atmosphere is also the answer to this question. How high should the price on carbon dioxide be? Because the price should be equal to this, the extra net present value of the global impacts that will be caused if you put one more ton of carbon dioxide into the atmosphere. It has the name of the social cost of carbon dioxide, and models like PAGE can be used to estimate what that number is. And it's the polluter pays principle. It's a very straightforward environmental economics principle that says that anybody who puts a ton of carbon dioxide into the atmosphere this year should pay something equal to the social cost of carbon dioxide, as the best way is to pay it as a tax, a climate change tax, a carbon tax, some people call it, as you have in British Columbia, and very few people do in fact have at a sensible level around the world. So how do we make that calculation? Well, we just put on some extra tons of carbon dioxide and see how much that affects the net present value of the impacts. So we must find the net present value of the global impacts without this spike of emissions today, and we find the net present value of the global impacts. If we put on a spike of emissions, extra emissions, we subtract the second answer from the first answer, and then we divide by the size of the spike. And the spike that we use is 100 billion tons of carbon dioxide. I won't go into why that is, but we can talk about it in the discussion if you like. And that tells you how much extra impact is being caused by putting on one more ton of carbon dioxide into the atmosphere. I can see you all desperately want to know what the answer is to this. So here's the answer that comes out of the model. As the total impacts have this very weird shape with a long right tail, so the social cost of carbon dioxide also has this weird shape with a long right tail. It could be that the number is up $500,000, $1,500 per ton of CO2, if we're really unlucky. But what we really need to take account of is this whole distribution here, and the mean value that comes out when you look at the whole distribution is a little bit over $100 per ton of CO2. Okay, so it's in 2010 it was about $110, but I round it down to say a little bit over $100 because it's a round number that people can get their mind around and can keep thinking about. So that's what it should be. That's what the price should be. That's what a carbon tax should be. I like to call it a climate change tax. That's the value it should be if we're going to make polluters pay for the damage that they're causing. What does that mean, though? I won't talk about that one because we're running out of time a bit. What does that mean in practical terms? It sounds at the moment as though this is horrible. You know, there's a bill for climate change. We've got to pay the bill. We've got to pay extra taxes. This is medicine. This is nasty. And actually, it isn't nasty. It isn't medicine. It's a milkshake. It's really nice if you follow this through to its logical conclusion. Because in the UK, and I don't know the economy of British Columbia or Canada enough to translate these figures over to Canada, but I know there are some people in the audience who do know the economy well enough and they can do it. In the UK, if we had this climate change tax, it would be equivalent to £80 UK per tonne of CO2 in 2015 in present day values. And what would that mean? It would mean that every litre of petrol, of gasoline that was sold, would increase in price by 20 pence, 0.2 pounds. Typical retail price in the UK is lots of tax on it already. It's about 115 pence per litre. The exchange rate between pounds and Canadian dollars is almost exactly 2 to 1 at the moment. So a pound is almost exactly 2 Canadian dollars. So if you want to translate this in your head to Canadian, then it's quite a simple thing to do. It would mean that every kilowatt hour of gas used in the home would go up by about 1.5 pence, 3 cents. Typical retail price in the UK of gas is about 4 pence per kilowatt hour. So although this isn't a huge increase here on petrol, because a lot of it is taxed already, gas in the home isn't taxed very much already, so it is quite a significant rise in price. It would lead to about 6 pence per kilowatt hour going on the price of electricity that you get from coal, 12 cents. 2.5 pence per kilowatt hour on electricity from gas. Gas is cleaner than coal, doesn't emit so much greenhouse gas, so the extra price on electricity from gas is lower, about 5 cents. The UK typical retail price is about 12 pence per kilowatt hour. So, you know, it's again a significant increase. And it will be about £60 on a return air ticket from London to somewhere in the south of Europe. I picked Barcelona there. Who knows what we have these low-cost airlines, which you may well have over here as well, Ryanair, and you can pay anything from £2.99 to £300 for that ticket, depending on when you go on their website. But £60 on a return air ticket is actually quite a substantial increase in the price of air travel as well. So this would lead to all sorts of changes in behaviour. It would lead to renewables who wouldn't have to pay this climate change tax because they don't emit greenhouse gases, suddenly looking much more cost-effective and much more favourable compared to generating electricity from coal or even from gas. It would lead to high-speed trains which can run on electricity from hydro or again from non-polluting sources, looking much more favourable than air travel. As long as there was something that was in place for a long enough time, there would be all sorts of changes in behaviour and changes of activity that would result from this. And all the studies suggest that if you have this kind of level of price, then you would see very dramatic drops, at least 80%, it's been worked out in the UK, over the next 25, 30 years, maybe 40 years, of drops in emissions of greenhouse gases. So we'd really be doing something serious and sensible to deal with the issue. But here's why it's a milkshake. It's because if you're getting some revenue from your climate change tax, you can reduce the other taxes in the economy that everybody hates paying. In the UK, if we put on this climate change tax at the sort of level I'm talking about, you would be getting total revenues of the order of £50 billion, 100 billion Canadian dollars per year from the climate change tax. And if we're really lucky, the emissions might reduce by 30% in the next 10 years or so, but the tax rate should increase by about 30% over that time because we're getting closer and closer to the time when really nasty things might happen, and therefore if we put a ton of CO2 into the atmosphere in 2025, it's going to cause worse effects than if we put it into the atmosphere now. So the tax should increase over time. And the total UK tax revenues are of the order of £500 billion a year. So you will be getting 10% of your total tax revenues from this source. And what would that mean? Well, you could make the choice. As citizens and governments can decide what they would do with that revenue. Here's one potential thing that you could do. In the UK, basic rate of income tax is 20%. You could reduce that down to 15%. That will cost you £20 billion a year. You could reduce the sales tax that we have from 20% to 16%. That will cost you another 20 billion. Then you'd still have about 10 billion left over for doing things like protecting the poor, the vulnerable, the elderly from the effect of the price increases. We have winter fuel allowances for pensioners in the UK to make sure they don't freeze in the winter. That costs us about £2 billion a year at the moment we could increase that to £5 billion a year. And you could support research and development into new innovative technologies. You could have information campaigns. You could do all sorts of things that are required in order to inform people about what's going on. Maybe spend £5 billion on that. This is all illustrative, okay? You decide as citizens. You decide how you want to spend that £50 billion of revenue. And you can reduce the things that we all hate paying, the other taxes. I'm not going to go through that in detail because it's a bit too complicated and there's too much detail there, but I'm happy to deal with why I think a climate change tax is the best way forward rather than other things that you can do like cap and trade systems or subsidies that people are suggesting you can do for different energy sources. There's all sorts of reasons why I believe that a climate change tax is a better solution than those as the foundation, as the cornerstone of your policy. I'm not saying you shouldn't have any subsidies for new technologies. You should have that for ones where there's some public goods there. But the cornerstone is better to be a climate change tax. And, you know, it's not just this crazy guy from Cambridge who's saying these kinds of things. There are actually supporters around the world for this. Academics, analysts. Bill Nordhaus, who's probably the grandfather of analysis of climate change, is a strong supporter of this. Paul Ekins ran a commission called the Green Fiscal Commission in the UK, which came out very strongly in favour of changing our taxation system away from taxing income and employing people and sales taxes onto taxing things we want to discourage, like pollution and climate change emissions as part of that. And as we've seen before, I had a quote from Christine Lagarde, the managing director of the IMF, who was very strongly in favour of countries having these kind of pricing systems put in place. And there are some governments. Okay, Sweden is the highest number. It comes out at the moment at $168 US per tonne of carbon dioxide, their climate change tax. But I mean, that sounds wonderful, but actually it's very restrictive, and there's only a few sectors that have to pay it, and major energy users can get away by putting in efficiency from paying the tax, and it only covers a fairly small part of their emissions. The UK actually has this thing called the carbon floor price for the last couple of years, which is effectively a climate change tax. It's now at about $35 US per tonne of CO2. So it's you know, not as high as I think the number should be, but it's not negligible. And of course, when I give this talk anywhere around the world, the third example I always put on there is British Columbia, because you've had your climate change tax. Now $30 Canadian, exchange rate's about $23 US per tonne of CO2. So again, you know, you're doing well, you're making it happen, but not quite at the kinds of levels that the evidence seems to suggest we should be putting it at. And there are several reasons actually why the tax should be higher than this $100 number that I've put forward if you're honest about the analysis. Well, one of the things is that, as I said before, the model only looks out to 2200. The world isn't going to end it, well, we hope the world isn't going to end in 2200. We'll assume it's not going to end in 2200. So actually, there's some impacts that might occur after that of anything that we put into the atmosphere. Even today, CO2 stays in the atmosphere, most of it for decades, some of it for a century or so, and about 20% of it stays in there essentially forever on a human timescale until it's absorbed into rocks and so on. So some of the impacts from the CO2 we put into the atmosphere today will carry on beyond 2200. And with some little experiments that I've done with the model looking out to 2400, it seems as though the price should be about 50% higher if you look that far out. But of course, you know, looking that far out is crazy. We don't know what the world will be like in 2400. But you know, it's one reason why we might have an underestimate from the model. Some of the impacts are not there in these integrated assessment models. The one that's most worrying and that isn't there is the possibility of war. Possibly that climate change might be so bad that hundreds of millions of people might be displaced from their homes in, let's say, parts of Asia, and will have to move into other countries. And that might lead to war between different countries. You know, no economists have been brave enough to make an estimate of just how bad that will be in economic terms, so I can't put it in the model. But it's not impossible that this could happen. So it's another reason why the estimate from the model is probably on the low side. Canada is actually 16% richer on average than the European Union. And one of the interesting things from the research is that the richer you are, the higher the climate change tax should be. It shouldn't start off at $100 per tonne in India and China. It should probably start off at $10 or $15 there, because they've got these immediate concerns of trying to feed their family, Africa in particular, trying to stay alive, and therefore it's not right that they should be paying the same level as us to start with. We should have a higher number. In the US, it should probably be about $250, because they're even richer than Canada. But here it should be probably 20% higher than the number I've calculated for the European Union. It replaces other taxes which themselves have bad effects, so you should be replacing as many of those as you can, and maybe even a little bit more than the climate change impact should tell you, because the tax on climate change is a tax on something we want to discourage rather than income taxes, which is a tax on something we want to encourage. And the social cost of carbon dioxide actually grows over time. I've hinted about that, but this is how it grows over time. According to the models, here's today, here's what it looks like if we emit CO2 at various points up to 2050, and the tax should grow at about 2.5% a year in real terms. That's the sort of number. So again, British Columbia had this right earlier on. You were growing the tax over time in real terms. You stopped doing that a few years ago. But that was indeed what the analysis would say you should be doing. You should grow it over time. So what does this all end up doing? Why is it a milkshake? It's because you're reducing the other taxes. What's the effect of reducing the other taxes? It is by and large that your economy grows faster than it otherwise would have done. So with a climate change tax in place, not only do you not destroy your economy, but on average your economy will grow faster than it would if you were taxing income or industries or sales in the way that you have been doing up to now. And the modelling on that relies on the fact that we have some structural unemployment in our economies, and if we make it cheaper to employ people, or people can spend more of their money because the sales taxes are lower, that structural unemployment decreases, your benefits payments decrease, your economy grows faster. So not only are you solving the climate change problem, but you're stimulating your economy as well. By the way, your emissions reduced by 60 to 80% as a result of doing this. So, all right, I will do this slide because I got 2 minutes left. All right, so I will show. Okay, I will show this slide. In my view, one way that you can tell how serious we are as a country or a region or any geographical grouping about dealing with climate change is by doing this calculation, calculating this index. You look at the percent of your emissions that are covered by carbon pricing, and you look at how big the carbon price is compared to where it should be. Okay? And the index, which I have tentatively called the HOPE index, says the price as a percent of CO2, the social cost of CO2, times the percent of the emissions covered, which is this area inside this rectangle here, will give you an estimate of just how serious a country or a region is about tackling climate change. So here's the answer for the UK. Because we have this carbon floor price, which takes the total price on CO2 emissions in the UK up to about $35 US, it applies to about 40% of our emissions in the UK, because it only applies to things like large power stations, large industry, things that are covered by the emission trading scheme in the EU. So we have this little rectangle here. 40% of our emissions are covered by a price that's at about 35% of where it should be. So that gives you a HOPE index of 14 for the UK. If we were really serious about tackling climate change, you would want to have a HOPE index of 100. You would want all your emissions to be covered either explicitly or implicitly by a price that is equal to the social cost of carbon dioxide. So the UK is actually one of the better countries around the world in terms of thinking about this issue. We have a Climate Change Act, we have targets to reduce our emissions by 80% by 2050. We've got this carbon floor price in place, yet even the UK only has an index of 14 rather than 100. I don't know what the answer is for British Columbia. I'd be really interested if somebody could do that calculation and see whether it's better or worse than the UK. Is it higher than 14 or not? But what's almost certain to be true is that it's not at 100 in British Columbia. We're not actually putting on the prices either explicitly or implicitly that we should be doing, and they're not covering the total range of emissions from fossil fuels, from power stations, from agriculture. There's methane from agriculture as well as CO2. We're not covering all of those in the way that we should be. And that's all I wanted to say now, because I want to give Mark a time to respond to this, and then I want to have plenty of time for questions, because I'm sure, because I've just gone through and described this as though it's all so obvious that nobody should disagree with it, that I know that people will have questions about it, and I want to allow plenty of time for that. So I'm going to stop there, Arnie. There's the references if anybody wants to follow this up in the academic literature. Thank you.
Is this on? Yes, it is. So, as you know, we record these, and I had the website up. When I put up the title, I'll put the website up again at the end. So you will be able to find this in a week or 2 or 3 weeks, and you can follow this up. So I don't know if everyone knows this, but SFU actually is home to the senior environmental economist in Canada, and his name is Mark Jacquard, and he's going to do the 10-minute or 15-minute or 5-minute, or I don't know him well enough to know how long he goes on. Response, he is an extremely busy man. He did a Pechakucha last night downtown for the city of Vancouver. He's a fellow of the Royal Society of Canada. He's written several books that have won several prizes. He did his PhD in Grenoble, actually. But he's been at SFU for quite a long time, and he is one of our stars. He is the Distinguished University Professor, and I'm not going to go through all the things that, you know, all the awards he's won and all that stuff. But to nab him and bring him here is quite something. So we should be listening very carefully to what he has to say in response to everything that you were all listening very carefully to before. So, Mark, please, 10 minutes.
Thanks, Arne. It's working? Okay, good. So I think this will only take maximum 10 minutes, and I can have 4 bullets, and people will say, you said, Anyway, stop me at 10 minutes, please. Yeah. So one thing I was going to say, Chris, is maybe ask me later in the question period about the HOPE index, because, on the electricity side, our implicit price is over $100, and I'll explain why if we get into that. But I'm actually going to just make a few brief comments, sort of to contextualize a bit the work Chris has done, and then as quick as possible get it into question period. So think of all the questions you want to ask, because I really think this is not about coming here to listen to me. We've got a very distinguished scholar here, and we're very lucky, and so I want to get us quickly to that phase. So I'm just going to make a couple of comments. One is the idea of models. So a lot of people will inherently say, I don't trust modelers. And so I'm going to defend to those people, if there's any in the audience, people like me and Chris, and the sort of standard message that I think he would have, but he can correct me, is that whenever you have to make decisions, there's implicitly, you are using a model. You may not have written it out, but you've made some assumptions about trade-offs or information you accept and don't accept and relationships between things. So we who build models simply try to make that explicit to help with decision making. But of course, then we're academics and so on, and those models can get more and more complicated. But if I were to ask Chris anything, it would be, boy, but I think you've done a great service, and I mean, Bill Nordhaus started it, and then you have done, to me, you guys are the pantheon of modelers, but it's very difficult because your model has simplified natural systems And I noticed when you spoke even at SFU yesterday, some of my colleagues who are professors on the climate science side, and you must run into that all the time. How do you decide how you're going to simplify, represent the natural system? I think Bill Nordhaus would say he's always bouncing ideas off of scientists that are around him at Yale and MIT, so maybe that's sort of where you'll go, but that's an interesting challenge to us as modelers. Then I'm just going to talk about, there's a hierarchy of models, so, or at least in terms of applications. So the modeling that Chris does, these 3 models in the world are actually combining the human economic system and even the non-economic system, but how we somehow value it, so polar bears, I call it that, with Earth systems and all the feedback effects in them of oceans, atmosphere, and terrestrial ecosystems and so on. And then, and so what they are doing is actually trying to tell us the optimal path for increasing or decreasing carbon dioxide emissions, for example. And that can also really bother people because that it's sort of, so you're saying there's an optimal path for CO2. Shouldn't we just stop polluting immediately or as fast as possible? But in fact, there are trade-offs. How fast we reduce CO2 emissions. And part of that is because humans over the years got a lot of benefits from using fossil fuels. And I find I have to tell that to people. There are a lot of benefits from fossil fuels. And so what Chris's model does is it finds that, that trade-off between the benefits and costs of the path we take. And I think that's very valuable, again, for making explicit what's going on here in decisions. Down the hierarchy from there are these global energy economy emissions models who don't have the natural system in there. They put out emissions, but they don't say how it's going to affect concentrations in the atmosphere in general and how that affects the oceans and weather systems and so on. So they basically are taking information like the social cost of carbon dioxide or politicians distilling that and saying we shouldn't go past 2 degrees Celsius. Here's what that cap should be on emissions to achieve it. From the scientists, and then saying, what does it cost us to do that? And then finally, but they're still global, and they break up the planet into regions. And then finally, there's the modelers like me, or when the Environmental Protection Agency is taking information from your model and saying, what kind of vehicle emission levels should we have in the United States, or what kind of coal power plant regulations, the US government has a model that I call politician-specific models. So those are models that are broken down to the level of where decision makers would use them, be that in a national government, a regional, subnational government, maybe a city government, and of course they can be multiple groups of countries as well. And so we have a model which name is SIMS, doesn't matter. The US government has a model called NEMS. And that's where, and our model was used when British Columbia was designing the carbon tax, for example, because we can then say, when you do this mix of models, what might it cost? And we can even help with things like the HOPE index, because implicit in what you were showing was that some policy instruments have one explicit cost for carbon, like a carbon tax, but some have an implicit cost. We have a regulation that you can't build a coal or natural gas plant in British Columbia. Well, it turns out coal and natural gas are really cheap. So if you have that regulation and you're not building those things, then we're doing renewables of various kinds, right? Run-of-river hydro, waste wood from forestry, wind, some solar. They're actually, if you ignore the damages, they're more expensive. So there's an implicit cost. And we estimate, or my PhD student has estimated over the years our implicit cost of our electricity regulation at somewhere between $75 and $125 per ton Canadian as a part of that. And of course that then covers all electricity, because just because we're a hydropower system doesn't mean it's all easy for us in British Columbia, because actually we have, as you know, a lot of natural gas that we can't even get rid of. The Asians won't take it. The Americans won't buy it anymore. So its implicit price is really low, and likewise our coal. So I'm almost done. So I want to talk about those hierarchies, and so that's where we get down to the kind of policy questions that we look at. But that's where this is a wonderful dialogue, and I want to say that when you put a quote in there from Bill Nordhaus saying that raising the price of carbon is a necessary condition, and I was thinking of taking issue with that, and then I noticed that in some of your final comments you said an explicit or implicit price of carbon. And if I can translate that for you, and you can correct me, that regulation we have on electricity, or California's regulation on vehicles, or its regulation on fuels, those are also putting a price on carbon, sort of. They're not a carbon tax, they're not a tradable permit price, but implicitly, someone like me with our model, we can calculate what the implicit price is that's going on there, just as I did with electricity. And the reason I wanted to bring that point up is when we get to the solution side of it, which is the theme that we're talking about here, then, and Chris, and it's been so wonderful to have Chris here for 2 days, because a lot of the work and modeling I do is sort of dealing with the real world that we have to deal with because of the flaws in our politicians, but even more importantly, the flaws in us. So some of the politicians are really badly flawed, and I won't say who or what, but there's an election coming up. But others, I've worked with a lot of politicians who really wanted to do something, and it was really difficult, because we do this rational process of, here's how you'd have a nice carbon price, you put the tax on, it's the most efficient instrument, don't worry, you get the money back, can't be any better. And of course, our experience in British Columbia, and some of that I've been telling Chris, is about how much misinformation comes out at a time like that. And you end up in a totally different world than the university world. You're in a world of lies, blatant lies by people who have a lot of money and a lot of access to media. And so we've been doing a lot more work on the social science side, where we realize that people say, well, some of the people who love carbon tax will say, well, you didn't do a good enough job advertising it. We did. There was a lot of advertising. They said, well, but you didn't give people a check right away. We did give them a check right away. It went on and on like that. And they said, but most people will benefit from it, because it'll just be a small percentage if you set it up right. We did. And we told people 80% of British Columbians are benefiting from the carbon tax because industry was getting hit a bit more, and the way it worked out. And nobody believed that. Surveys showed that 85% thought they lost from the carbon tax. So my point is, carbon pricing, very important if we can get it, but it may have to be implicit in cases. And so let's see how we can design the solutions, the policies, so that there is as close to efficiency as possible. And there's ways that we can get at that as well. But none of this gets anywhere if we don't have people doing the incredible work that Chris Holt and his team have been doing to help set the whole context. And I know that even within Canada and the federal government, even the Harper government has people working in government as they try to negotiate regulations who look at your numbers for the social cost of capital. And so it's really wonderful to have you here, and feel really blessed that we've all got a chance. And so I want to open it up for discussion, but I wanted to just also thank you for
sounds like an advertisement. Okay.
You take the
So
questions.
you two
I go
over
over
there.
here, right?
And
I'll sit on the floor here.
Okay, yeah, we'll stay over here. And the floor is open. So questions for either of the speakers. As usual, I'll try to push it back to the audience so everyone can hear it, and that the speakers can hear it as well. So please, sir.
Hi. I made a film called Running on Climate where I interviewed Mark. It's Robert. Hi, Mark.
Okay.
And in the interview, I asked him about what the price of carbon should be, and I think he said something like $200. So I was just curious as to why there's such a discrepancy between the $100, $200, and how firm can we be about that price?
Right. So the question is, other people, including Mark, have suggested that the true cost, the price per ton, should be more like 200. I think this question
Oh,
also
so wait a
per
minute.
ton.
That I have said that publicly? Yeah, because that's when, just to explain for Chris, our Prime Minister 9 years ago made a promise for the year 2020 and then did nothing. And so I worked with the National Roundtable, our group, in 2006 and 7 to calculate the carbon price we would have needed in Canada to meet the target in 2020. And that price, I don't think, ever went above $100. But with each year, if your target is only 13 years away, with each year of delay, then you have to be more aggressive in the short time period you have. And I came out with a reporting less than a year ago, I think, in which I estimated it would be $200. You'd have to go to 200 almost immediately now. So maybe that's where you heard it. Yeah.
But the general question is,
Yeah.
there's a wide range
Yeah.
in possible prices, and
But-
can you comment a little bit about that?
Yeah, Mark, you don't have to feel embarrassed about having $200 rather than $100, because the $100 that I was talking about is the mean answer in 2005 US dollars for emissions in 2010. So it goes up at about 2.5% a year in real terms. And if we bring it forward to 2015 and put it into 2015 US dollars, that number comes up at about 130 US dollars. If we put in the exchange rate between US dollars and Canadian dollars, I can't quite
We
do it
don't-
in my head, but
we don't like talking about that.
I know you don't, but I've got to do it. So it probably comes up to about 175 Canadian dollars. And if we then factor in the fact that Canada is 16% richer than the EU, then we got pretty much to the $200. So that's, I think, actually, if we sit in this room here in 2015 and thinking about what it should be in 2015 in Canadian dollars, 200 is probably a closer number than 100. So we've come to the same thing. Mark says it needs to be 200 in order for it to have the right effect. I say 200 is what you can justify on the polluter pays principle for the damage that you're causing. So this is really a nice coincidence. Because we're coming at the answer from two different directions. One is what it would have to be, and one is what we can justify. And it happens to be that they're pretty much the same number. So that's really good. Nice first question.
But
Thank you.
if Stephen Harper wins re-election and still does nothing, and still just keeps saying, "Oh, we'll make that target," my number's going into the thousands fairly soon, because we're just moving towards that year. And then just the point to remind people is that when we put out these numbers, we do try to be really careful, because often it's actually a price path that's rising over time. So I try to qualify it, but just sort of one number gets out there, and I'm sure you have that challenge as well. I saw in your earlier talks, that is it the price path? So there is no one price, or are you then bringing it all back into current terms and the way banks can discount money? Anyway, it's complicated.
Sir.
I have two questions. I have two questions for both the speakers, or one of them on the platform. One is, can you help me get my head around a ton of carbon, CO2, which is a gas? Second question is, if we charge a carbon tax of $100 a ton, give or take a few, then do we flatten, or do we stop the increase of carbon in the atmosphere at its present level?
Okay, so what is a ton of carbon? I wanted to ask you that question too.
It's
That's the first question.
It's a good question, and it's not something that we all have in our minds, and it's why I put up the slide where I was trying to put it in terms of the extra cost for a litre of gas and a bit of kilowatt hour of gas and a kilowatt hour of electricity and a flight. Because I think that's, when you're trying to get your mind around just how much you will increase the prices, that's the best way to do it. It will increase the cost of electricity from coal by about 50%. It would increase the cost of gas by about a third, something like that.
A litre of gas is 2.5 kilograms of CO2.
There we go. That man knows.
Gasoline in your car.
That man knows the exact one. Thank you, Hadi. That's the exact comparison. And just because it's a gas doesn't mean you can't measure it in tons. Of course, we can do that. So that's fine. So that's the first thing. But what will it do in terms of our concentrations in the atmosphere. Now, there's two things here. It will almost certainly reduce our emissions of the greenhouse gases quite significantly. According to McKinsey, according to Bloomberg, who've done their studies of how much it will cost us to do all the things that might reduce the greenhouse gas emissions, renewables, energy efficiency, changing ways in which we travel, changing the patterns of our cities over the longer term. They've looked at about 50 or 60 different technologies, different things that might flow from this. And nearly all of those can be brought into play at a price of less than $100 per tonne of CO2. So we can end up reducing our emissions quite significantly, maybe get them down close to zero over a time scale of 50 or 60 years. It's that sort of time scale. Unfortunately, that doesn't mean that the concentrations of greenhouse gases in the atmosphere then go to zero, because the concentrations are a lagged function of emissions over the last 100 years or so. So it takes a long while for reductions in emissions to end up being reductions in concentrations. So, we need to start tackling the problem by reducing the emissions quite rapidly in order to stop the concentrations going up to that 700 parts per million that I put on one of the earlier slides. And if we're really lucky, the present day concentration is about 400 parts per million. We may well, if we're really lucky and we work really hard on this, be able to stop it going up beyond about 500 parts per million. You know, to get it much below that would require such huge and immediate reductions in emissions that it's very hard to see how we would do that. So we're in for a bit of a rocky ride, because the concentrations are probably still going to go up for the short term, and we will probably see rises in temperature of 2 to 3 degrees, whatever we do, if the scientists are right. But if we don't do anything, those rises will be 6 degrees or more by next century.
Here in the middle, and then we... Yeah.
I have a question for Dr. Hope about the model. I was surprised to see that the cost was rising linearly with time, and that it doesn't go exponentially or power law, as my intuition tells me that these climate effects of climate change could actually be exponential. I would think positive feedback cycles would predict that, so I thought maybe the cost would mimic that. The other part is, what is the main driver driving up the cost there? Is it sea level rise? Is it drought, loss of farmable land? What effect did you play with it to figure out what effect is actually driving up the cost the most?
Yeah, those are two,
So do you want to repeat
two
the question?
excellent questions.
Sorry, would you like to repeat the question?
Yeah. So the slide that showed how it rises over time, if you were viewing it from the angle that I am here, you would see that it is actually exponential rather than linear. It goes up at about 2.5% per year, so it's an exponential rise. So your intuition is exactly right about that. What in terms of the things that are being the biggest drivers? The model has sea level rise, economic impacts, non-economic impacts, and these catastrophes. The slide that I skipped over showed how much of the impact is coming essentially from these catastrophes. It turns out that when you do 100,000 runs with the model, the top 1% of those runs, the worst 1% of those runs, which is where the catastrophes occur, are giving you 22% of your price on carbon. So quite a large part of the social cost of carbon dioxide comes from the worry that we might trigger something very nasty like melting of Greenland and West Antarctic ice sheets. Non-economic impacts are actually the second thing that's very big in contributing to the total. As we get richer and richer as time goes on, we put higher and higher values on ecosystems, on polar bears, on whales, on human health, all these kinds of things. And we are expecting that we will get richer. The scenarios that I'm basing this work on at least show that. So those non-economic impacts and the valuation of those are actually very significant over time. The third thing that I just want to mention briefly, because I didn't know whether I was going to be able to talk about it because I didn't know whether it would be published yet, but it came out on Monday, a paper in Nature Climate Change, is the feedbacks that are occurring in the Arctic. The Arctic is warming twice as fast as the rest of the globe. If it carries on doing that, then permafrost up in the Arctic will fall. And there will be huge releases billions of tons of methane and probably hundreds of billions of tons of CO2 from that permafrost. And we published a paper on Monday in Nature Climate Change saying how much worse that makes the impacts of global climate change. And the answer is it increases the impacts from about 400 trillion to about 450 trillion US dollars. So it's quite a significant thing just from a small part of the world that we tend to have neglected up to now, but is quite a serious part of the problem. And if we see the ice continuing to decrease as it has been in the past, then this is something that we should be very worried about. And it's just an additional reason to cut back our gases and have a significant price to make sure we do that.
And the point there is that the models you used for the inputs don't include that melting yet.
No, they haven't included the 400 trillion US dollars, didn't include that thawing permafrost, it didn't include methane coming out from under the East Siberian Sea, because the best global circulation models that the scientists use typically have not included those kind of feedbacks that would occur later in the century. So we wanted to just make a first attempt to put them in by combining a scientific model that we have from the National Sea Ice Data Center in the US, which can model how much the thawing permafrost might release, and putting that into the integrated assessment model to see how bad that will be in terms of worsening the bill for climate change.
Sir.
Thanks. Just based on my quick calculations, I think BC's at a Hope Index of about 21. So we're doing slightly better than UK.
Very good.
Still not quite enough. I guess my question is, notwithstanding the conversations we've just had around whether it's $100 a ton, $200 a ton, if we go beyond that threshold, if we go beyond $100 a ton, what's the profile of the changes that we see? Is it linear? Do I see twice the impact if I'm at $200 a ton versus 100? How it relates to that policy sphere and the rate at which we can use a higher price to accelerate the changes, or if it's literally just keep stepping through and get it as high as you can, or whether there is more of a curve to it.
So did everyone catch that? So if it's $100 a ton, then we get a certain response. If we increase it by the price quite a bit, what sort of response do we get? And this is sort of the feedback, right?
Yeah. Do you want to?
Well, I was confused if you were talking about the optimal solution in his model, because my model is an abatement model, and so it, of course, is getting more and more expensive, depending on the time frame, to go. So as we go to higher increments of price, we get less reduction. But we're not integrating the whole system.
No, I guess in essence that's my question. How do we reconcile those two different approaches with what is in essence a common approach, the pricing of 1 ton of carbon?
Yeah, I mean, I think it's a very important question, and people like McKinsey and people like Bloomberg have studied this, and they produce what they call marginal abatement cost curves, and they are curves, they're not linear, so that's, your intuition is right, it's not linear. But what they found is that there's quite a lot that can be done with things like energy efficiency and just small shifts in behavior at very low costs. And then we have a sort of plateau of quite a lot of things that come in at around about $40 to $50 per ton of carbon dioxide that becomes economic. The onshore wind power in favourable locations looks very good. Mode switching of transport can do things for you at that sort of price. And then there's a tail that goes up beyond that, and there's not so much that seems to happen above about $60, $70, $80, and then you get to the $100. So according to McKinsey, we can almost entirely decarbonize our economy if we take the right decisions, if we had a carbon price at around about $100 per tonne of CO2. But of course we don't take the right decisions. So quite a bit of their curve is actually at negative cost. The stuff that we should be doing today, even if it didn't bring any carbon dioxide emission benefit, that we don't do, like properly insulating our homes and using entirely low energy light bulbs rather than more energy consuming light bulbs. So, you have to deal with the fact that the real world is not quite the same as these marginal abatement cost curves are, which is why I don't want to go so far as to say, actually, if we just have a price of $100 per tonne of CO2, we will definitely decarbonise everything, because the world just doesn't work that way. And indeed, that's a lot of the work that Mark has done, is to show that the world doesn't work that way, and we need to either have higher prices or we have to have other measures to try and move people in the right direction.
Hi. I'm just wondering if you could speak a little bit about your experience presenting this type of analysis to senior decision makers, and kind of what adding up to a bill of $400 trillion, what kind of impact that has, you think, when you're presenting the information. Is it actually useful to them, or does that actually motivate their action?
Right. So what do senior policymakers make of your model? And I think, Mark, you might want to speak to this as well.
Go ahead.
It's a great question. The first time that the kind of modelling that I do was really significant in the policy process was when the Stern Review happened in about 2006. Nicholas Stern was tasked by the Prime Minister in the UK and the Chancellor of the Exchequer, the Treasurer of the UK, to do this kind of calculation of what's the economics of climate change, how bad might it be. And he decided to use the model that I'd created in order to try and work out what the impacts were. And that then became enormously influential because he came up with a number which said it's equivalent to losing 5 to 20% of our GDP in perpetuity. And he had to do some extra calculations beyond what the Beige model did to get to that number. He did what's called a balanced growth equivalent, which I won't go into the technique of, but in order to be able to project things through beyond the 2200 horizon of the model. But that then, really shifted the balance of discussion about this. This is a serious problem that maybe is equivalent to losing 5 to 20% of your GDP, and on most estimates of what it will cost to do something about this problem, to cut back the emissions, it's of the order of 1 or 2% of your GDP that you'd have to spend to do that. Okay? That was, he was then, by using the modelling, able to give this message to the Prime Minister, to the Treasurer, to the civil servants, who then set up the Climate Change Act to have the reductions of 60 to 80%, which we now have by 2050 in the UK. So that was enormously influential. Now, the other thing that I find is more influential now is not this total bill of 400 trillion. It's the marginal amount. It's the social cost of carbon dioxide. And the way that it's beginning to get into decision making, even in places like the US, is by the civil servants taking the models and running them with their own assumptions and coming up with the values that they can then sell to the people who have to sign off on them and say, yes, this is a price we want to use. So the model that I've talked about today, as well as Bill Nordhaus's DICE model and another model by Richard Toll, are the three models used by the US Environment Protection Agency in order to try and calculate what the price on CO2 should be in the US. And they come up with a mean number, not of $100, but of about $40, because they've used slightly different assumptions in the model. But that's, to my mind, that's okay. People who want to use the models, if there's anybody serious about using the model either for policy analysis or for serious academic research, I give the model away. Okay, I'm just interested that they have it there as a tool that they can use and put their own assumptions into it. What's their assumption about discount rates? What's their assumption about climate sensitivity? They can use whatever they think is valid for them and their situation, and they can work it all through as to what the price should be. And in the US, and those kind of calculations that the EPA have done, and Mark mentioned them very briefly, they're beginning to have some sort of influence on policies and rule making and so on in the US. They don't have a climate change tax at all of this sort of level, but some states are beginning to think about the level it should be, and that's going to come out of these US EPA calculations as well. So, the total was good at the beginning with the Stern Review, and now this marginal thing of the social cost of carbon dioxide beginning to have an influence even in the US.
So if I can just add on, so in effect, it is not acting as a carbon tax, but it's in the sense of an explicit price of carbon that then reverberates through your economy and signals to everyone. It's an implicit price because it's what's used to determine the intensity of a regulation that reduces emissions by regulating technologies or fuels. And so that is what's going on there. And I just wanted to add, Chris is being too modest. Your number of 100 is higher, and there's just a whole bunch of recent academic literature that is really supporting your number better than those low numbers. And even the EPA, the Environmental Protection Agency, in the document where they say we're using 40 for now, say we really think the number's higher than this. There's just a lot of stuff that's not in here yet in the treatment of catastrophe and so on. And I think the subtext is, and we feel we'll get beat up by Republicans and eliminated if we don't do it. So, yeah.
So if I can just, to follow on from that, because I thought it was a really interesting question, and beat up by Republicans made me think of it. Yeah. Why did the Prime Minister of the UK go to Nicholas Stern and say, we need this report? Like, what's the story there? Was it someone who knew somebody and they had coffee? Or what was the, do you know? Why did the UK do it first?
I wasn't in the room when that discussion was held.
Who was in the room, yeah.
So, Nicholas Stern was the chief economist in the UK government at the time. So he was the obvious person to do this kind of study. He was an entirely establishment figure. They thought he was a safe pair of hands. He was somebody who would come up with, something that was really justifiable, defensible. And they really wanted, as far as I can tell, to know the answer. It's unusual for politicians, I know, to really want to know the answer. But they didn't before he'd done this study. There was all sorts of little studies going on and floating around in academic literature. And they wanted, it was a little bit like a mini IPCC, which brings together the assessment of all the research around the world and says, is this any good or not? They wanted to have him look at this specific issue of what can we say about the economics of climate change? Is it a really serious issue or not? And I think they were probably a little bit shocked when he came up with a quote that it's the greatest market failure the world has ever seen, which is what he said as a result of his studies, because I don't think he actually believed that at the beginning. I think he was swayed by the evidence that was presented to him and the analysis that he did himself. He used my model for looking at the impacts. He used somebody else's model for looking at what the costs of abatement might be, doing something about the problem. And he actually did form this opinion as he went along and was able to sell it to the Prime Minister and to the Chancellor of the Exchequer, who then set up the Climate Change Act, and all sorts of legislation has flowed from that. It doesn't have, until the irony is the Prime Minister who was in power at the time was Tony Blair, was the Labour Prime Minister, and he didn't put a climate change tax on. He did lots of other things like the Climate Change Act and quantity targets. It's only since we've had a Conservative government, which is more akin to the Republicans in the US, that we have got this carbon floor price, which is the closest thing in the UK that we now have to a climate change tax. So it's actually gone completely across the political divide. It's very different from the situation in the US. Conservatives, Labour, all on board with this being a serious problem.
Thank you. Here.
Firstly, thanks so much, Dr. Hope and Dr. Jacquard, for all your great work and for the talk tonight. I wanted to, firstly, you were discussing about, and I think it's such an important point, that we all sort of operate off of mental models or some sort of model that we base our decision making on. One that's occurred to me is we would have, if we don't do anything to mitigate climate change, a lot more people dying or suffering, and a lot more beautiful places destroyed than if we do. And so you can basically just say, if we can afford to do it, we ought to. That being said, I think if we could get $100 or $200 per ton of carbon, that would be just a wonderful accomplishment, and it's something that's worth fighting extremely hard for. I know you're both economists, not necessarily full-time political organizers or anything, but what do you see as the most strategic ways to actually try to get this out of the lab, as it were, and implemented?
I'm going to mainly let Mark answer that, because he's been doing much more groundbreaking work on translating this into real politics than I have. But I'll just take up your point before he answers the main thing. I don't think I said it in the actual talk, but you pointed out just how bad these impacts are going to be in poorer parts of the world. And the modeling that we do shows that it's between 85 and 90% of those total impacts are felt in the poorer parts of the world. They're felt in Africa, Asia, and Latin America. And so indeed there is this moral dimension to the problem, and a justice dimension to the problem that I haven't really played up here, but you've correctly identified.
And I think I should be careful about trying to answer this in any detail. I've done everything from writing a book about it with Jeffrey Simpson of the Globe and Mail to doing a 7-minute PechaKucha last night on this question that you've just asked. So that one will be online soon, so you can have the abridged version, because there's a lot of different aspects to it. So one is, it ranges everything from how does your governance system work? So there is some argument that proportional representation forms of government can be more successful with problems that are long-term and that sort of cost now but don't give benefits to the future. But the evidence is not certain on that. So you can still have an Arnold Schwarzenegger in California in that style of political system move ahead. Then it can be, oh, well, actually California has a long history now of trust of institutions that are given authority from the government and end up having strong regulatory authority. So it started with local air pollution, but the California Air Resources Board is, Arnold Schwarzenegger signed as governor and the legislation wrote an act that basically said, we as politicians won't be dealing with this anymore. They deal with it, but a lot of it is going to be done by this institution that's well trusted in the society, is arm's length from government, and has a quasi-regulatory authority. And so there's like models of governance that are better and worse. If we can't do those changes, then there's questions about how does one, act politically. And then for me, it's also how do I help people design policies that are more likely to be successful politically. So the first thing I say to my grad students when they arrive is I say, I don't want to hear anyone complaining about how stupid politicians are. If we think we're so smart, we should be able to design policies that they do the right thing and get reelected. And then you realize that's quite tricky. So there's really good work on that, and that's why I said I could talk on that forever, and I have a book you can look at on that. But there's so much that has been written about that. And so I think I should just, and then yes, the political process. So what I ended my PechaKucha with last night was I said, it looks, right-of-center governments can be keen to take action. When Stephen Harper came into power, he appointed me to the National Roundtable. Well, first he appointed me as an advisor to Rona Ambrose, who was the first Minister of Environment, and that was fun. I mean, she wanted to go places, but she got stopped in the cabinet. But then he invited me to he appointed me to the National Roundtable on the environment and the economy. And almost all the other appointees, I started to realize as I scratched the surface, had been former Conservative constituency presidents or had been the Conservative Nova Scotia minister of whatever. So they were all, Stephen Harper had said he was coming in to clean up who you appoint to government, but they all had some connection. Then what I found was as we dealt with Stephen Harper's telling us we have to have a 65% reduction by 2050, they all, it didn't matter that they were conservatives, they rebelled against Stephen Harper. They all came out, I couldn't believe it, and once they looked at the evidence, we got to have a carbon price, So Stephen Harper got rid of the National Roundtable. And so it occurs to me that you got to get rid of Stephen Harper. and so I ended my PechaKucha, but am I impressed with the other parties? No, because they're busy trying to make sure he gets reelected. And so I ended my PechaKucha talking about lead now, and it's our fault if we allow to split the vote in the crucial ridings that he would need to stay in power. And I tell you though, I'm happy to work with the conservative, a right-of-center politician whether it would be an Arnold Schwarzenegger, I'm an advisor to the California Energy Commission, or Gordon Campbell. So for me, I don't feel partisan on this issue, but there's a certain individual that has clearly demonstrated where his position is on this with respect to Canada, oil and gas, and climate.
So where has the mic gone? To the back.
Hi.
Then we'll come down.
Hi, actually, I have a very simple question. If governments establish or increase carbon tax, as an industry, should I increase my activities to cover my expenses and have more benefits, or should I turn them down?
I didn't quite catch the question. So if the government raises the carbon tax, then should you as
an industry,
yes?
should I increase my activities to cover my expenses and get more benefits, or should I turn my activities down to just get rid of my expenses?
So what should industries do with if they're
what
given
should
this
they
new
do with
tax?
it?
So these are carbon intense industries, I assume.
Yeah.
You're talking about, yes.
I mean, the answer is that industries do tend to be quite close to profit maximizing. They try to take the decisions which will lead to reduction in their costs and increase in their profits. So any industry that is faced with a different taxation system from one they've been used to will have to decide how to respond to that. Now, if you're an energy-intensive user, you may well end up reducing the amount of energy-intensive activity that you do, because it will be more expensive for you to operate, and you might end up with some negative results of that. On the other hand, if you're the 90% of the economy that is not an energy-intensive industry, then you will end up with lower costs, because you will have had your payroll taxes decreased, and you will have had sales taxes decreased on your products, and therefore you will see increased demand for them, and you will be increasing your activity, because that will far outweigh the extra costs that you will get from having to pay the climate change taxes. So overall in the economy, it's almost certain from what the models have shown that the activity will increase, that your growth of GDP will be higher if you have a climate change tax than if you have the array of incomes and sales and payroll taxes that we have at the moment. And the only time when that is not true is if you happen to be an economy where you have completely full employment, and therefore reductions in payroll taxes or whatever cannot lead you to employing more people. It can only lead to more competition, which leads to possibly greater inflation. But since the financial crash of 2008, there are very, very few parts of the world where you have this full employment, and therefore where climate change tax would not look so good. In nearly every country of the world, the activity will be higher if you have a climate change tax and reduce your other taxes than if you don't.
Here, and then we have over here as well.
Why is a carbon tax better than cap and trade?
Right. So, classic question. Why is it better than cap and trade?
In Europe, we have a huge experience with cap and trade and trying to make it work. Since the mid-1990s, when we first were thinking about how we would deal with this problem, and where we first thought we might try a carbon tax, but for idiotic reasons inside the EU, we ended up not doing so, because they wanted to levy the climate change tax at the centre of the EU in Brussels, rather than each individual country being allowed to levy their climate change tax. And every treasurer in the country said, no, we're not going to give up our tax-raising rights to you in Brussels. So that's why we ended up with a cap and trade system in Europe. And what we've seen is that for very short periods of time, the price has been at some sort of level of maybe $20 or $25, which might possibly have had some effect on activities that people have been taking. But for the vast majority of the time since we've had the cap and trade system, for various reasons, like over supply of permits originally that the countries were allowed to give out to their industries, recessions following the financial crisis in 2008, the price of the cap and trade permit in the EU ETS has been down under $10, around about $5 to $7 all of the time. So this is a number, when you compare it with what it should be at $100 per tonne of CO2, that is effectively doing nothing. It's not doing anything to stimulate renewables or low emission ways of doing things. And this is the activity that has the, probably, I would say certainly for climate change, the biggest effort being put into making a cap and trade system work. So if that history of nearly 20 years now has ended up with a price which effectively does nothing, that leads me to think that a cap and trade system is going to have huge problems wherever people try and put it in, because lobbyists will be able to argue that they should be given the permits for free, and they will be arguing for more permits being given out than should be given out, and that will lead to the price of the permits being very low. And we know that the price needs to be high. So if we know that the price needs to be high, why don't we just set a high price by putting a climate change tax on? And then it gets through all of these problems of you end up with an unanticipated low price because all sorts of funny things have happened inside this very complicated system you set up. So that's why I prefer a climate change tax to a cap and trade system. As an economist, theoretically, a cap and trade system with auctioned permits could work as well as a climate change tax. But in practice, it doesn't seem to have worked out that way.
Maybe I can, so we will differ, and we know that because we've had 2 days together. So, and the first one I'll go at is to say, we've had cap and trade, and it didn't get the prices we wanted, so the carbon tax must be better, but you didn't put in a carbon tax. So there's something else there. Yeah. And so my own position has been, for a long time now, that it's a mistake to fight about these different policies. The distinction I make is between compulsory policies that we know can reduce emissions with what I call faking it policies, like a Rick Mercer commercial series on how you can behave differently, which surveys show nobody understood. They liked the commercial but had no idea what they would then supposed to do afterwards. So we do a lot of work, and again, it's in that book where we distinguish the research literature on how people perceive policies and how they affect what they do, and we make this compulsory, non-compulsory. Now let me group together the compulsory policies. That could be cap and trade, which gets to an explicit carbon price. It could be carbon tax, which gets to an explicit carbon price. And it can be all sorts of regulations that have an implicit price. And the worst cases, the harm that someone does is to portray regulations in only one characteristic. Regulations, and I could go a long time and I won't, but look into or send me an email and I'll send you stuff on some intelligent aspects of the California regulations that mean that they're almost as efficient as a carbon tax, except they get implemented and the carbon tax doesn't. I see that as a really important thing. For 30 years now, I can talk about a carbon tax. Now, what's interesting is when Gordon Campbell came and said, I want to do a carbon tax, I did say, are you sure? Like maybe you should do cap and trade or something. In fact, his approach wasn't carbon tax. His approach was shotgun. In the matter of 6 months, he passed legislation to do cap and trade, to do a carbon tax, to do all of the California regulations on electricity, on fuels, on vehicles. And it's just the carbon tax happened faster, and then the recession came, and then he was gone. It was this ephemeral opportunity. But if you think about your reasons, you did save the situation there right at the end when you pointed out that of course we make mistakes in how we design anything, trying to foresee changing political developments, changing priorities among voters. And so people tried to protect on that. And so in California, their cap and trade has a rising floor price, which you sort of mentioned at the end, and I think that you're saying David Cameron has put that in the UK. And they were very careful about that. And when they linked up with Quebec, that's what they did. So there was huge negotiations between California and Quebec to have a rising floor price. So the problem that you're talking about, so you could say, well, that floor price doesn't rise enough. Well, it's rising faster than any carbon tax I see anywhere, right? So, if you can show me a carbon tax that's rising like that, fine, but you can't get it done politically. Maybe, but if you can't, do the next best thing that you can get a politician to do. If we're so clever, we should be able to figure out things that politicians can do, not that just we say, look how superior this is, but they're not going to implement it. So we missed one important part of research.
Question down here.
And with that in mind, there's the climate conference in Paris, the end of November, beginning of December. And so not just countries, but cities and I think maybe provinces and states will be at those meetings. I'm wondering if you can comment whether you're directly involved in any of those discussions or if you can comment on how your models are being used in the discussions at that conference.
Right. So how is what we've talked about here this evening, how is that feeding into the Paris climate negotiations in November?
Well, I can start off and answer quite simply. I'm not involved with the Paris conference. Some of the work that I've done feeds into some of the positions that some of the countries are taking at the Paris conference because it feeds into what they actually think the price explicitly or implicitly should be that you follow up with. But the difficulty with these kind of large-scale conferences is if we're not careful, what they end up degenerating into is certain parts of the world trying to force certain other parts of the world to do things that they don't want to do. To be explicit, they twist the arms of China and India up behind their backs to try and make them have some kind of limit on their emissions. And I don't think we are in a position to force China to do anything that it doesn't want to do. China is going to be the powerhouse of the next century. So what we need to do is demonstrate that there are things that work, that tackle the climate change issue, that don't wreck your economy, but actually make your economy better. And because by we I mean North America, Europe, the other advanced economies, have by and large been the first people who have put these gases into the atmosphere that caused the problem to start with, then we're the ones who have to demonstrate the technologies and the policies that work. And if we're right in the modelling, and if we're right with the limited experience that we have from British Columbia and Sweden and the UK now with some explicit carbon pricing, that it does indeed lead your economies to grow faster than it otherwise would do, then the leaders of China and India aren't stupid. They are going to notice this. They are going to want then to have a piece of that action. And we won't have to twist their arms up behind their backs at conferences like Paris. They will want to put in place these kinds of measures because they want their economies to carry on growing fast and growing well, and they want to tackle the climate change problem as the same as we do. But it has to be done in a way, as Mark has said, with local politicians. Same thing applies to countries across the world. We can't force them to do anything that they don't think is in their own best interest.
Mark, did you want to say something about that?
Well, just so our model is a national model, so the Canadian government has used it. Well, actually, it was funny. The Canadian government, when it went to Kyoto, did not use our model or even its own internal models. The orders for the negotiators was to be close to the United States, Al Gore or whatever he was doing. So this was Canadian industry was very irritated with this, and so was Alberta and other jurisdictions after Kyoto, that Canada signed it without doing any economic analysis. The Americans had done economic analysis. So we did some voluntarily, and then we did a lot afterwards. And we did some before Canada went to negotiations in Copenhagen, for example. We did it for the Canadian negotiators. But in terms of that process itself, which Chris talked a little bit about, I'm not a huge fan of everybody coming together and making a deal like that, because I think its probability of success is zero. You'll get a deal, but it actually will be non-compulsory. And so you are more of a voluntarist. I am more of a true economist. I say you're going to have to use sticks as well as carrots to do a global agreement here. And maybe we differ or maybe we don't. But I would like it if we didn't have to do that. So one book I'd advise you to think about is David Victor's book, Global Gridlock. Because this is the talk these days, is that instead of these, or let those big things go on, those big processes, but really try to get small multilateral or bilateral agreements of key players. And Obama tried to do that in 2009 in Copenhagen, right? He went to Copenhagen and didn't go to the negotiating sessions. He went into a hotel room and he brought in South Africa, China, India, Russia, Brazil, and tried to cut a deal. And now he's the sort of the people I know in senior, and I'm way down, but who I hear rumors in the US government levels, their strategy for the last few years has been to try to negotiate. That negotiation with China that led to an agreement was part of a strategy that had been mapped out once Obama administration knew it wasn't going to get a Congress and the Senate that would help it to have extra force when it went over. Because remember, the bill that almost passed, all the bills that have been in the United States that have almost passed, the cap and trade bills, even one that passed the House of Representatives but not the Senate by one vote after Ted Kennedy died, the Waxman-Markey bill, that had a measure in there that said that if United States trading partners, after 5 years, don't have an equivalent price on carbon, that price on carbon will be put as a tariff on the imports of those goods. And I think you have to do that. And so I just think you're going to end up with some bilateral stuff like that. People are talking about clubs, that you're going to make clubs of people who want to act first, but those clubs will eventually, I hope they won't have to use tariffs, but I bet you they will. Yeah. And so I wouldn't discourage it, because it may be how you have to get there.
So we have a question at the back, then we're going to come down here in the front, and then you might be done, yeah?
I just wanted to bring it back to the model for a moment. You mentioned earlier that 20% of your price comes from the top 1% in your estimates. So you're very sensitive to your tails there. And the wag in me wants to say, are those tails even integral? You're talking about really far out climate scenarios, 7 degrees warmer than now. How are you going to feed a population of 8, 10 billion, whatever we're going to have then? It sounds pretty existential at that point. Does it make sense to take a mean here?
Sorry. So this is a question I think I had yesterday at the talk, was a lot of this modeling seems to be very sensitive to these catastrophes that are way out there, because if you remove them, you get quite a bit lower. So that part I understood. So you were saying you're uncomfortable with that, but then you said that how are we going to deal with feeding 10 billion people? I just missed the connection.
It's the same question, really. So the tail, the very far end of the distribution, corresponds to climates that we cannot imagine, really. We have no handle on how much it'll cost if global mean surface temperatures go up by 7 degrees. What's the effect of on GDP? How can you? The question is, how do you estimate that? Because the consequences of that for economies, as far as I can imagine, are kind of almost unsurvivable in the way we know modern economies.
Your intuition is right, that we have very little data on what a world that's 6 or 7 or 8 degrees warmer might look like, and therefore what the impacts might be. And therefore what I have to do at the moment in the model is have extremely broad ranges for just how bad a climate catastrophe like that would be, how fast it might come on, what kind of threshold we might have to cross in order to get to it, and what the effect will be in terms of losing percentages of GDP. And what I make all the time plea to economists who I know are working on this is, rather than trying to sort of project onwards and say, well, we think we've got a handle on what it might be at 2 degrees, and then it might go up as a quadratic function till we get to 8 degrees or something like that. That's not the right way to do it. Let's get some of the brightest environmental economists and climate economists to study from first principles what a 10-degree world warmer world might look like, or whatever we think the extreme end might be. And that then gives us a chance to narrow down these ranges that I have to put into my integrated assessment models. Because I can't create certainty from uncertainty. You know, if these studies haven't been done, I have to honestly reflect them in the model as being extremely wide ranges. But one of the most important things that could narrow down these ranges as to what the price on carbon should be or what the total impact should be would be if some really good climate economists would do those first principle studies of what a 8 or 10 degree warmer world might look like. And, you know, I just don't know the answer at the moment to that, and I don't think anybody else in the world does. I think the furthest anybody's done with trying to look at from first principles is Mark Linus, I think, looked at a 6 degree warmer world. And, you know, that's the furthest I've seen anybody go, and we need to go further than that.
You have a question down here. Might be the last one.
Yes, there's a couple. The first one, I was hoping to hear something about the stranded assets, the global carbon budget. And the second one is where you're getting your data on the carbon emissions, whether it's EIA, IEA, or total, or some of the forms, because I know there's some serious problems with how they define liquid fossil fuels, your energy densities of these fuels, and the increased energy extraction costs and such. So please, your opinion or
right.
your information.
So the first question is one that is discussed a lot here in Vancouver about stranded assets. And so
yeah,
can you just comment on that?
Yes, I can comment on whether there is such a thing as stranded assets, and indeed I think there might be some stranded assets. Whether they're stranded today, I would rather doubt, because these things are going to play out over a timescale of decades, and people will make choices which will lead to certain assets not having quite the full lifetime they otherwise would have had, but they probably won't be abandoned straight away. But I have to, you know, to be honest, I have to say I don't really care if some of your assets are stranded. Okay? It's probably because you made a bad decision in the past to invest in those assets. And this is happening all the time. People make bad decisions and the assets don't live to the full lifetime that you expected them to have and don't carry on producing because you made a slightly bad decision. And what we end up is just turning over the capital stock a bit faster, and we bring in these low emission renewables or carbon capture and storage or whatever it might be. So, you know, I think that's okay. That's just part of the creative destruction that we have all the time when we're having these kind of markets and organizations that we call capitalism. In terms of where the numbers come from, where the emissions come from, I tend to use scenarios that come from the Intergovernmental Panel on Climate Change, who are the guys who have looked most effectively at what might happen to emissions over the next 100 years or so. And they put together different families of scenarios. Some of them are worlds which are a bit like today, growing reasonably well and people getting on with each other in a reasonable way, and some are much less rosy than that. They lead to the world fragmenting and less trade and so on. So that's where I tend to take both my socio-economic scenarios, what's going to happen to GDP, what's going to happen to population, and my emissions scenarios from. And then you can run the model for different scenarios that people might have. And the number that I came up with, this $100 per tonne of CO2, is for business as usual emissions under the A1B scenario. But you could also have a scenario where you end up cutting back your emissions quite a lot and look at what the price of carbon dioxide should be under that scenario. Turns out it should probably be about $75 rather than $100, because you're not causing such severe problems, and therefore every extra tonne is not causing you so much extra damage, and therefore the price should be lower on it. So you want to play with all the different scenarios. I didn't have time to talk about lots of them tonight, but it's a good question. Thank you.
Are there any? So we have gone. This has been kind of like a masterclass. I kind of feel like this has been pretty sophisticated discussion. Are there any other? Does anyone have another burning question? We are at 9 o'clock, and I think right at the back.
It's fast.
That's good. Just holler it out. Just holler it out.
So the prices you have in your that you're predicting for 6 pence for a liter of gas, I think you said, are those numbers for? Or are they based on known known consumer reaction? Like, is that a number that's actually going to make people produce less carbon? Like, I know you've presented a economic benefit of that number, but is there there's two sides to this, right? Like GDP help plus the carbon, which is the name. So, like, is there any social research done on how much do I have to pay for gas to actually stop driving?
Yeah.
Right.
Yes, there is, and that's Mark's. That's Mark's research, which you described very well. Mine is from the other side, which is how bad is it when you burn a litre of gasoline, and therefore how much should you be charged for the damage that you're causing? And at some point these estimates will end up meeting in the middle, and that, if you believe in economics being able to define for you what the best or optimal route should be, is where these two numbers coincide, where the damage that's being caused by 1 extra tonne of carbon dioxide being put into the atmosphere is the same as the cost that you would have to pay in order to stop putting that extra tonne into the atmosphere. That sort of tells you roughly the path you should go down. But that's a whole nother 2-hour session of whether we should be going for optimal emissions and doing calculations with the economics in order to try and get us there.
So I think we should invite Chris Hope back for another session next year, and then we can find out. So, we've thanked everybody many times. I want to thank Mark Jacquard and Chris Hope again. I think this was incredibly educational, and we've learned a lot. We won't have a session next week or the week after. We'll come back on October 15th, so it's not every week as it has been in the past. It is here, room 1900, that's this room, right, Laura? So we're here. The last one, we're not going to be here, so I'll remind you. And it's going to be another Canadian luminary, from Mark, David Boyd, who's written a book called The Optimistic Environmentalist, and the respondent is actually here in the audience. It's Dr. Malcolm Shield from the city of Vancouver. So we're going to hear now about renewables, I think, very specifically, and about what we're doing locally on that file. So I think it will be just as educational as this evening. So thank you all for coming. Tell your friends.